Hello, good morning, guys. Our lesson for today is going to be about digital. I hope you've heard of digital. Digital are basically into bytes. They are into bytes. Computers understand they understand digital, whilst we humans we know of analog. Now, to begin with, we are going to use digital to blink our LED. Now, first of all, in doing so, when we look at our Arduino, especially on our Tiny Lab, we are going to see 4-button tap. Now with this 4-button tap, we are going to use our 9th and then the 8th button tap to control our 12th LED. If we want, we can control our 11th LED. If we want, we can also control our 13th LED. But now we are going to use to control our 12th LED. The LED number 12. The LED number 12 also corresponds with our button pin 9 and 8. Now to begin with, we have to define the pins and the LEDs we are going to use. Now we begin with define. We define it. Define LED pin. Now let's say 12. Then we defined our button pins. Define button. Let's say we can make it I pin A pin, okay? A pin to differ in the name. The name should be different, okay? 9. Now here too we have our defined button bare pin. We can make it C pin, no problem. Now we have it as 8. We have it as 8. Now we come to our void. We have our void setup. This is a must. It is always a must. It has to be there. Void setup has to always be there. Now in our void setup, what do we have to do? In this void setup, we are going to basically use our pin mode. If you have usually we use pin mode in our setup. What does this mean? It means it runs once in our program. Now I have our pin mode. At the top here we have defined our LED pin 12. So our LED pin is actually going to be our output. It's going to be an output that is going to blink. The LED pin number 12 is going to blink. So we're going to make it as our what? As our output. So we write LED pin. We write our pin mode. Now we write, what is the name? We write our LED pin. If we want, we can write LED pin. If we want, we can write 12. But as long as there is LED pin and we write LED pin here, it actually our computer actually realizes that we are using 12. So we now write here LED pin. You can also write 12, no problem. LED pin. Now we have our comma. It's going to be our output because this output is basically telling us that it's going to blink. We are going to release something. It's going to release something. That means it's going to blink. Now we have our pin mode. Our pin mode. With our pin mode. Now button pin. If you write this button R pin, it basically tells us that the 9, and the 9 is also corresponds with S1 on our Tiny Lab. Okay. Now we have input pull up. Pull up, it helps us activate the connected digital resistors. You understand? It helps us activate the connected digital resistance. It activates them. Now we have input it pull up. Normally here we're supposed to use pull. We're supposed to use input, but we're using input pull up in order to control our resistors. Like it should control it with the digital. It should make sure it is uh, activated with the digital. Now we have our pin mode. Okay, can you guess? That is button B pin, the B pin. It's also going to be our input pull up. The reason why we are actually making the on input and here input and here output is that this output is going to blink it, but this button button A and then button B is basically what we are going to use to control our LED pin 12. Meaning if we press on our button A pin, it is going to switch on our LED. If we press on the button B pin, it's going to switch off our LED, meaning there will be a blink, but with our control of these two buttons. That is why we made it input. Input actually means we are going to tap, we're going to press something, we're going to enter something for an operation to occur. Now let's close it. We have closed it. Now we come to our void. What can you guess? That is our void loop. Void loop. Void loop. Okay, void loop. You open it. Void loop. Void loop, as we say, it runs and runs once again. It runs again continuously. Now our LED is our output. Okay, now our LED is our output. Our button is our input. Now our buttons are there, our input. Okay, because we're going to press on them, that means they are in our input. Now we have our void loop. In our void loop, right now, let me say this way. Let me comment first of all right now. A button pin. Now I'm going to comment before I write it. A button pin is pressed on LED. It's first of all pressed on LED. It's pressed on our LED. Now let me explain what I'm trying to talk of. Now, as long as we're talking about digital, okay, we're talking about digital, we're going to use the digital to control them, okay, to control our button pin. Now we say if digital read, button A pin is equal to low. What do I mean here is equal to low? It means if digital read, when a digital reads it, button A pin. Why do we use digital read and not digital write here? Because here is input, so here is going to be a digital read. Okay, button A pin is low. If it is low, if it is off, now we open it. If it is off, now we open it. We say if it is off, we say digital read. Sorry, digital write. We write it. Now we have already read it. So if it is that way, that means we write it. That means we write it. We write it. That means if it's that way, that means we write it. That means we show it to be what? We show it to be. We show our LED pin. We will show our LED pin. Our LED pin to be high. We show our LED pin to be high. Now we close this one. Then we write for the distance too, for the second the B pin. Now we have B button pressed on our LED. Now we say if, okay, can you guess? Digital read, digital read. The reason why we're using digital read, as I said, is because it's input. When it is input, we use digital read. When it is output, we use digital write. Okay, digital write, meaning here is going to release something, our LED pin. Because here's our LED pin, that is why we use digital write. So it's going to be digital write. If it is that way, it means when it is off, okay, we should on our LED pin. Okay, if A pin is off, that means we are going to on our LED pin. Now digital read. Now we write button B pin. Okay, it's also low. If it is low, actually, if it is low, we say digital write is going to write it. Okay, digital write. Well, our LED pin is what is also low. If it is low, if it is off, then our LED pin is also what, off. I think you are moving with me. If it is off, that means our LED pin should also off. Basically what we are trying to talk of here, then now we close it, we have closed it. What we are basically trying to talk of here is that if our B pin is open, like our B button is pressed, here digital read. Why we use digital read? Because it's a button pin and it's an input, so we use that. If it is off, we mean it should, our LED should also be what, off. Here we mean if our digital button A is also off, we also say digital write, our LED pin should be what, high. Our LED pin should be high, that means it should on it. That means with our button A pin, that means the S1, our button A pin is basically the S1 on our TinyLab. We are going to switch on the blink. It's going to be switched on. And then with the button S4, that is the B button here, which corresponds with 8, we are going to basically off it. That means when you press on the S1, it's going to blink. When you press on the S4, it's going to off. That means we are going to use these two button pins, the 8 button pin and then the 9 button pin, which corresponds with the S1 and the S4, to control our LED. Thank you for listening. This talks about our digital. Thank you very much. See you next time.